Hello and welcome. In this video we want to do some questions about the continuity of the functions. Consider this function. F of x is a piecewise function and it is defined as negative x to the 2 plus x plus 3 if x is less than 1. If x is greater than or equal 1, but attention, if x is greater than or equal 1 but not equal to 3, the function f of x is radical 3x plus 6. So we can use this equation for f of x if x is greater than or equal 1 but not equal to 3. So you can use this equation for any value greater than or equal 1 but not 3. So what we have for the 3, what is the function f of x where if x is 3? It is given 2 if x is 3. So the function f of x is a piecewise function and it is defined as you can see. Now we want to answer these questions. We want to find some limits about this function. The first question is find limit of this function when x approaches 1 from the right. What is limit of this function when x approaches 1 from the right? First, you have to figure out which equation between these three equations you have to use for finding this limit. Because x approaches 1, but from the right, this is the equation we have to use. Because x is greater than 1. Because x approaches 1 from the right side. X approaches to 1 from values greater than 1. So we have to use this equation based on this rule that here we have. So for finding this limit, we say this limit is equal to limit of radical 3x plus 6 as x approaches 1. Simply you can find this limit by direct substitution. If you plug in 1 for x, the limit is radical 3 times 1 plus 6. It is radical 9 and it equals to 3. So the limit of f of x when x approaches 1 from the right exists and it equals 3. The next question is what is the limit of this function when x approaches 1 but from the left? Now which equation we have to use for finding this limit? Because x approaches 1 from the left, x is less than 1. So you have to use this equation for finding the limit. Limit of negative x to the 2 plus x plus 3. Simply if you plug in 1 for x, the limit would be negative 1 to the 2 plus 1 plus 3. And this equals 3. So the left limit is also 3. As you can see, the left limit and right limit are equal to each other. So what we can conclude from this? We can conclude that limit of the function f of x when x approaches 1 exists because the left limit and right limit are equal to each other. What is the next question here? We are asked to find f of 1. This is not a limit, this is just find the value of the function f of x when x is 1. If x is equal to 1, we have this equation. So for finding f of 1, we have to substitute 1 for x in that equation. And this is simply 3. Next, we are asked to find limit of the function f of x when x approaches 3 from the left. Look at these equations and figure out which equation we have to use for finding limit of f of x when x approaches 3 from the left. This equation is only for x less than 1. So forget this. This equation is only when x is equal to 3. But here x approaches to 3 and from the left, so it is less than 3. You have to use this equation because you can use this equation for any value greater than 1 but not equal to 3. When x approaches to 3 from the left, you can think it as something like 2.99. So it's a close number to 3, something like 2.9999. And that number falls in this region. It is greater than 1 but not equal to 3. So for finding that limit, you have to use radical 3x plus 6. So we have limit x approaches 3 from the left of radical 3x plus 6. If you plug in 3 for x, you have radical 3 times 3 plus 6, and it equals radical 9 plus 6 is 15. The limit is radical 15. Then we are asked to find limit of function f of x when x approaches 3 from the right. Here also we have to use same expression, radical 3x plus 6. Why we have to use same equation? Because, attention again, if x is greater than 1, not equal to 3, use this one, this equation. And when x approaches 3 from the right, it's a close number to 3, something like 3.001. And it falls in this region. So you have to use that equation. So the limit would be the same. Radical 3 times 3 plus 6 is radical 15. Because the left limit and right limit are equal to each other, so limit of f of x when x approaches 3 exists. So the function has limit at 3. Then we are asked to find f of 3. When x is exactly equal to 3, f of x is equal to. So what is f of 3? F of 3 is simply 2. After all of these calculations, we are asked find the points that the function f is discontinuous. So after all of this, we are asked to find the points that the function f is discontinuous. At which points this function is discontinuous? If you look at our calculations, simply you can notice that f is continuous at 1. Note that the right limit, left limit, and f of 1, all of them are equal to each other. So f is continuous at 1. But if you notice to the left limit, right limit, and f of 3, what do you notice? Limit of f of x when x approaches 3 exists. So the function satisfies the condition, one of the conditions of continuity. But the problem is that the limit is different than the value. Limit of f of x is not equal to f of 3. So f is not continuous at 3. So what we can say about these points of discontinuity? Function f of x is not continuous only at x equal to 3. And what is the reason for that? Because limit of f of x when x approaches 3 is not equal to f of 3. But attention, f is continuous at 1, because if you look at the limit here, limit at 1 is 3 and f of 1 is also 3. So f is continuous at 3. but f is continuous at 1, because limit of f of x when x approaches 1 exists, and it is equal to 3 based on our calculations, and it equals f of 1, which is also 3. And of course, this piecewise function here is continuous at other points. We checked only point 1 and point 3 and not any other points, because this expression here is continuous for all other values that are less than 1. Radical 3x plus 6 is always continuous if x is greater than 1. So we didn't check other points. The only points that we have to check for this piecewise function to find the points of discontinuities are only 1 and 3. By checking those points, we find that f is continuous at 1 but is not continuous at 3. So the only point of discontinuity is 3. Let's do another question. Here we are given this piecewise function, a bit unusual piecewise function. If you look, you can understand why I am saying a bit unusual. The function is this: g m m over r to the power of 3 if r is less than r. I forgot to write r here. And if r is greater than or equal capital R, the function f is g m m over r to the 2. Let me explain a bit about this given function. This given function shows the force. So suppose this given function shows the force exerted by the planet Earth. So this function shows the force that Earth exerts on an object with mass m. And suppose the mass of the Earth, so suppose also mass of Earth is capital M. So the big M shows the mass of the Earth. The small m in the function shows the mass of the object. But what is that g and what is that capital R? The g is the constant of gravitational force. It's about the physics. I'm not going to explain what is g, but consider g as a constant. So g is a constant, capital M is constant, a small letter m is also constant. What about that capital R? The R shows the radius of the Earth. So now everything should be clear. The capital M shows the mass of the Earth. The capital letter R shows the radius of the Earth. What about that letter R, the small letter r? What is that here? The small r shows the distance of the object from the planet Earth. So the only variable in this equation, is only r, which is here and here. Other things are constants. Attention to this. Everything else is constant. G is constant, capital M is constant, small letter m is constant, capital R is constant. We are given this function, and we are asked to check the continuity of this function at R. So we want to check if this function is continuous at R, the capital letter R. So let me write down the question. Is function f continuous at R equal R or not? This question is a bit confusing for the students because they usually see x as the variable, but here this question R is the variable, and we usually prefer to work with numbers, not letters like G, M, R, and so on. So if it's a bit confusing for you, it's completely normal. So we want to see if this function, attention, the variable of the function is R, everything else in these equations is constant. Is this function continuous when R equals R or not? As you can see from the equations, the equation of f of R changes when R is less than R or greater than R. That's the reason we are interested to check continuity of this function when R equals R. If you remember the definition of continuity at a point, first we have to check, is the function defined at the point or not? So first we start with f of R. We want to see, is this function here defined at this point or not? This is the first condition of continuity. If you pay attention here, when R equals R, greater than equals R, you have to use this equation. So for finding the value of the function when R, the small letter R, equals the capital letter R, I have to use the second equation, and it equals to G M M over R to the 2. After this, we have to find the right limits and left limits separately. Because when R is less than R, we have one equation, R greater than R. Another equation, we cannot find the limit. As a two-sided limit, we have to find left limit and right limit separately. So I'm going to find limit of the function f of R when R approaches R once from the right, and limit of the function f of R when R approaches R from left. When R approaches R from the right, R is greater than R, so we have to use the second equation. What was the second equation? It was G M M over R to the 2 as R approaches capital R from the right. Simply, if you plug in R to find the limit, direct substitution works, and you can find the limit. It would be this. Let's see what is the limit from the left. Now we have to use the first equation, which is G M M M R over R to the 3. So we have to find limit of G M M when R approaches R from the left. For finding this limit, also we can use direct substitution. It would be G M M R over R to the 3. One R from the top with one R from the bottom cancel each other, and it would be G M M over R to the 2. As you can see, the right limit and left limit are equal to each other. This shows that limit of the function f of R when R approaches R exists. And if you look at the value of the function at R, it is also equal to these limits. So this shows what? This shows that the limit exists and it equals to the value, so the function is continuous. So all of these calculations shows that the function f of r is continuous at r equals capital letter R. And basically, in general, this given function is continuous everywhere in its domain, because the first equation is continuous everywhere, the second equation is also continuous everywhere, so this function is continuous in all of its domain. And don't forget, the variable in this function is r, the radius, not the radius, the distance of the object from the planet Earth. So r is basically a positive variable because it shows the distance. R cannot be a negative variable here. I hope you liked this video. If you liked this video, please subscribe in my channel and see you in the next videos.